Hi, once again. We are going to study today some angle relationships in circles. So let's go ahead and get started. Unfortunately, I don't have a studio audience with me today, so it's just me. I'll get you through this nonetheless. We're going to pick up a couple theorems today. The first one here says, if a tangent, which is this one, and a secant intersect a chord at a point of tangency, which in this case is B, then the measure of the angle, this angle right here from AB down to BC, is half of this arc AB. So let me go mark that up a little bit for you. So this whole angle right there is half of the arc AB. And we're going to go do some problems now and make that clearer for you. Okay? So, in our first one here, we're going to go find angle EFH. So this is the angle. This is the tangent here, EF, and there's the secant, FH. In this case, it's a chord. And what this tells us, in this case, is that the angle, or the arc measure is 130. So using this formula right here, we can say the measure of angle EFH is equal to 1/2 the arc between the tangent and the chord. So 1/2 of 130, which indeed we can figure out is 65 degrees. So this angle here then would be 65 degrees. In the next problem down here, we're finding the measure of GF. Okay? And what we need to do is we need this angle here, and then we double it to find the measure of the arc. Well, this time it's a little tricky because we first have to go calculate 180 minus 122. And that gives us that the measure of this angle is 58. So, the measure of the arc GF is going to be 2 times the measure of the angle, and therefore it is 116. Hopefully I didn't make any mistakes there. So that's how you use this theorem. Moving on to the next theorem, if two secants or chords intersect in the interior of a circle, you can see they intersect in a place that's not the center of the circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So one more time, that this angle right here is half of the measure of that arc and that arc. So let's go figure out what this means over here. That means that if I'm looking for this, and we're going to call that angle X, and we could also call this angle X because they're vertically opposite angles. So to go find X then, so measure of ABD, which is X, we're going to say equals X just to make our life easier. X equals, and it's going to be half of the sum of this arc here and that arc there, which is going to be 65 plus 37. And we're going to go type that in over here. So that's going to be 65 plus 37, enter, divided by 2, 51. So X is 51 degrees. Now, we could also now find this angle right here by taking the supplement of 51 degrees, which would be, what, 129? Moving along. The final theorem today is if a tangent and a secant, two tangents, so this is a tangent because it only intersects at one place here at D, or a tangent, that's a secant, or two tangents, you can see this is a tangent there, and that's a tangent there, or two secants. Okay, wherever they intercept, that angle that they make, that angle, that angle, that angle, is going to be equal to half the difference of the measures of its intercepted arcs. So in this case, it's 1/2 of that minus that. Or here, in the case of two tangents, it's this minus that, 1/2 of that minus that. Or in this case, it is 1/2 of that minus that. But the key thing that you remember here is it's half the difference of the measure of its intercepted arcs. So, in this case, they gave us what we're looking for, and we need to go calculate x. And we're going to use this one right here. So they gave us the angle, so we're going to say 25 equals, and now it's going to be half the measure of the intercepted arcs of the 25. So here are the two secants, and it's going to be the big one minus the small one. So 1/2 of the big one minus the small one. I always like to get rid of fractions first when I'm doing equations with fractions in them. I'm going to multiply both sides times 2. And then through the magic of mathematics, they went away. The fractions went away. And now we're going to subtract 83 from both sides. 50 minus 83, probably could have done that in my head. Negative 33 equals x, negative x. So x is equal to 33 degrees. So once again, the key thing here is that we're taking half the difference of the measures of the intercepted arc. This was the intercepted arc here, and that's the, and that's the intercepted arc right there. So 25, the angle formed by the two secants, is 1/2 that minus that right there. All right, got a couple more problems for you to hear. 2 of the 6 muscles that control the eyeball movement are attached to the eyeball and intersect behind the eye. So here's where they're telling us they intersect right over here. If the measure of AEB 225 from here to A to there to B, 225, what is this measure of this angle C here? We're going to call it X. Well, we need to find the measure of both intercepted arcs. We know this one, but how are we going to go find this one right here? Well, you can see they definitely add up to 360. These two do. So we're going to go take the 360 and subtract off what they gave us, 225. And in fact, AB is 135. So now we can go use this formula right over here, saying that it's 1/2, that this angle is 1/2 the large part minus the small intercepted arc. So angle X is equal to 1/2 the large minus the small intercepted arc. And let's go do this on the calculator so we don't make any mistakes. 225 minus 135, and we divide that by 2. And indeed, so this is 1/2 of 90, which is 45 degrees. So you can see, with two tangents like this, you simply take 1/2 that arc minus that arc. And these two arcs together add up to 360. Our final problem today is by far the trickiest. And we want to go find the measure of the arc YZ. In order to do that, we first need to go find this measure right there. So step number 1, find the measure of arc UY. Okay? And then once we know UY, and we know that that's 49, we can go find that one. So let's go find UY. Well, we know that these two angles right here, we're going to call this X and 113 are supplementary. So the supplement of 113, once again, we can do it in our head, but we'll use the calculator to just be careful here. And so 67. So x is equal to 67 degrees. So why don't I go write that in there? I'm going to erase that, and I'm going to write that as 67 degrees. All right. So we learned that this angle right here is equal to half of this minus that. And we're going to call this one that we're looking for y now. And let's go use the formula. Okay? So we're going to do 67 degrees is equal to 1/2 the sum of their intercepted arcs, which is y plus 68. And as we did before, I want to get rid of that. So 67 times 2 is about 134. Therefore, y, and I'm going to use the calculator on this because I tend to make mistakes when I'm doing these videos, so I'd rather use the calculator. 66. Does that make some sense? It does. So this intercepted arc is indeed 66 degrees. This right here. Okay? So now, and let's go ahead and write that in. I'm going to write that in. It's 66 degrees. Now, I'm looking for this part right here. Using this theorem that we talked about over here, saying that the external angle is equal to the difference, 1/2 the difference of the intercepted arcs. I'm going to use that now, saying this external angle, let's go like that so I have more room. This external angle is going to be 1/2 of that minus that. So here we go. Let's call this W. So we're going to say that 49 is equal to 1/2 the difference of the intercepted arcs, which is W minus 66. Get rid of my fractions, and I get 98 equals W minus 66, or W equals 98 plus 66, 164. So the measure of angle YZ is equal to 164 degrees. And that's it for today. So today we've gone through, I know it was a bit complicated, but just go through if you have any questions. There's some great explanations in the books with even more examples. But I'll expect you to do this type of problem in class Monday morning. That's all for now. Have a great day.